Hello! So, let's talk about functional programming. And let's talk about what I think are some things you should do and some things you shouldn't do. Do's and don'ts. So, one of the things that I absolutely love about functional programming is that when you start thinking in terms of pure functions and isolating logic, basically, you get this best practice that a lot of the code gurus of the world will call loose coupling. So what do I mean about loose coupling? I mean that you get code that is isolated to a single function. It doesn't create dependencies like around itself, which means that it's very easy to plug in and pull out of any flow of logic. Why is this beneficial? Well, it is beneficial because it creates what I call disposable code that is easy to throw away. Because if code is easy to throw away, it becomes easy to change. If it's easy to change, it is, per definition, in my opinion, the most easy to use and maintainable thing that you can have. Maintainability and ease of usage, I mean, if you think about it, the standard libraries in, say, JavaScript, such as math.random or math.power or ceiling or like floor or so forth, these are pure functions that you trust implicitly. You would never expect those functions to ever break anything like that. Yeah, they might misbehave a little bit, but that's another issue. But you feel secure in using them. That's usually why I argue that a lot of people who feel uncomfortable with abstractions are really only afraid of abstractions that are provided by their colleagues or some non-standard library programmer, because everybody trusts the collections in any language. Everybody, for the most part, unless you're a really hardcore scholar type of programmer, you usually trust the APIs provided by the language. Now, what does this have to do with what I think you should be doing in functional programming? Well, it's actually very simple. If you consider that these are the core values, creating pure functions and making sure that you have a lot of smaller functions that are doing these isolated tasks, and that your entire logic structure is broken out into named functions. Don't overuse lambda functions, don't do that. Make it a named function if you can. And the effect, at least for my opinion, what happens is that you'll find that you have files that are like, you have a lot of stuff going on in your files, you have a lot of different functions, but that's okay. I mean, you will see that as you progress, your function libraries go bigger and bigger and bigger, and some people will then tell me that, well, you're sooner or later going to duplicate yourself. And I say, well, yeah, but if you do it in a pure functional way, the beauty of that is what I was saying earlier. It's disposable, which means that if you have two functions, one week you're working on one set of stuff, you make your implementation specifically solving that problem. Don't try to be generic. Don't start off by doing that. You're just going to complicate things. Make it a specific solution, and all of a sudden you're working on feature number 2 a few months later, and you look at, oh well, it's very similar to this other thing I was doing earlier. Maybe I should go back and check how I did that. And all of a sudden you see that, hey, these two things that I made, the logic in these two functions, they're identical. And now you create your abstraction, or rather you create your reusable code. You didn't start out that way, but it was very easy for you to go into that. That's why pure functions, small pure functions that do just one thing, nothing else, are, in my opinion, the most powerful concept from functional programming. So that's a big do. Small functions. Always pass everything into a small pure function that performs your logic. Never ever use impurities within these functions, because it will create a problem. So that's a don't. So if you have, let's say that you need to do a database connection, and you need to get some data basically, and then you can do your computation. What I highly suggest that you do is that you put that logic, like the actual database access, separate that from the business logic that you're going to compute. And this becomes very weird to explain in words, but it's better to think of it as if you have a controller action handler and a request comes in and you need to get some data from a database, and then you need to do some transformations on that data, or you need to provide some type of logic and then send the response back to the client. Some people will create just one function that does all that in one go, and that's bad. Don't do that. Prefer to have a database access, grab the data, and then pass that into the pure function that's going to produce the logic. If you have that approach, your actual business logic becomes very isolated. It becomes very testable, because then your function that is supposed to be doing your logic doesn't care where it's getting the data. That's the key point here. It doesn't care. It doesn't matter if the data is in memory, if it's coming from a server, whatever. It's just a function that's taking an input. And that is so beautiful and simple to work with for everybody, for the consumers of your functions and so forth. So here, that's a big don't mix them. Never ever mix them. So apart from that, I would say that another big don't when it comes to functional programming, and this is a little bit controversial. This is going to be a little bit, well, I'm pretty sure I'm going to get some people who are disagreeing with this one. Don't use composition in the classical sense, currying and composition and monads. Why am I saying this? Well, I am saying this because the odds of you getting it wrong or complicating things for yourself is massive. The odds are massive. Am I saying that you can't do it? No, absolutely not. If you are a really good if you feel really comfortable with functional programming and you have been doing it for a long time and you have your shit together, you really know your stuff, then by all means go crazy. Make it, because they are powerful tools. But in my experience, or rather my personal opinion, is that most people who are these days talking about functional programming are really only talking about functional programming because it's very recently become a popular concept, and most of them are more sold on, as I was saying earlier, the pure function idea, that type of stuff. I honestly believe that that's the case. To them it's more a mentality or a way of writing code, because I have seen people who claim to write functionals that, they break all the core rules, and it's a really abstract term. Some people, honestly, the only red thread I've seen through the code that's produced by people who are functional is what I was saying, small pure functions. That's the only thing that they really have in common, and then there are a lot of deviations and other stuff. So currying, composition and monads, use them if you have to, but trust me, for the most part they're really tricky to find a really strong use case. They're not, in my opinion, they're not going to be your bread and butter. They're not. They are useful, but I don't think they are this type of thing you should be using left and right, because you're probably going to misuse them. That's my opinion anyway. So what does this all kind of boil down to? Well, it's actually very simple. The one big thing I want you to take away from this when it comes to functional programming is the idea of always having a function, a small pure function, that takes in all it needs to perform its computation. And if you have that approach, most of your code will actually become very, very easy to maintain, because it's all functions. So yeah, that's basically my biggest tip to you. Start thinking in terms of small functions that produce that are pure, and you know, if you need to a little bit of an elaboration of what it means to be pure and so forth, there are some great reading materials on the net. But start out by doing that, and don't get bogged down into the really high level advanced functional stuff, because it's just going to be getting your way to start off with.